Okay, so let's look at the custody profiler itself and the applications. So custody profiler may be used to examine custody provision force-wide or to size individual facilities. And examples include sizing your proposed new facilities, evaluating the effect of increasing or decreasing the number of custody locations that you have in your current force, identifying the optimum location for your custody suites, calculating the number of resources required to deal with the demand, optimizing the number of resources available at different times of the day and the week, and developing and testing new shift patterns. So one thing I find quite interesting when we look at all of the custody suite or the custody work we've done in the past is obviously you get a surge of demand on a Friday and a Saturday night with arrests, but actually the busiest time of the week is Monday morning about 7 or 8 o'clock in the morning, because you've got all of the people going off to court that you've detained and retained over the weekend, as well as some of the proactive CID work, making lots of arrests, kicking doors down on a Monday morning as well. So actually the busiest time in custody can be Monday morning, and very often during the day you do drop down to fairly comfortable low numbers of people in custody. So when we do the custody projects, we obviously look at the historical data. We build the model accordingly and get that to validate against historical data. The question is, why would you simulate? Well, yes, you could use Workload Profiler and only Workload Profiler. I'd say that's a good starting point. That would give you the right number of hours required in a year to deliver the service, but it wouldn't give you the right number of hours per hour of the week, because demand is obviously unpredictable. So this week isn't the same as last week. Demand is time dependent, i.e. demand varies by hour of the week, as does the time at which certain tasks have to be performed, like breakfast has to occur around about sort of 7 till 10 o'clock in the morning, and lunch at lunchtime, and so on and so forth. The detention duration is also very variable. If you get arrested at 2 o'clock in the morning, the chances are you're going to need to lie down to sober up before you even get interviewed and then potentially released. So there's lots of things that vary by time of the week. The work content associated with individual arrestees varies. Some will have special needs, medical conditions to attend to. Self-harmers will need CCTV cells, etc., etc. And there are also constraints on the working hours due to police regulations and laws, and also finally the minimum staffing levels you've got to take into account. So there may be hours of the week where you've only got 1 or 2 people in custody, but your minimum staffing levels will still have to be adhered to in order to make sure the staff and the detainees are safe. So within our custody profiler model, we've got the methodology. So we seek, or you will need to get your arrest data, a load of your process data, and your resource data. So the arrest data is usually fairly straightforward because it's the people arriving in the custody suite. What can often be a little bit more difficult to obtain is where that person was arrested, because obviously you might know their home address, but they possibly wouldn't have been arrested at their home address. So in the custody suite system, there's often a link to the incident data, which will give you the location of the arrest. The process data very often comes from a workshop where we sit down and we populate the workload profiler to pick up all of the different activities that are done and how often they're done. And then your resource data will come from your HR system. And this all goes into your custody profiler simulation, from which you can get an array of output for Zymes to build your OPA and your SPA, your shift rota, which you can then put back into the simulation, test how different rotas would perform, to give you an idea of what your overall performance would look like. If you were to close a custody suite, then within the profiler, that would reallocate the arrestees to the remaining custody suites by whichever one's nearest, and rerun the model to see that you either need more people or you need more cells and more people in order to meet an acceptable performance level. Okay, so there are 2 files with custody profiler, very similar to response profiler. There's an Excel interface in which you can place all of your inputs. And this Excel workbook also contains sheets to present the results after the model has run. And there's a simulate model as well. So you configure your model in Excel. You don't need to interact with any of the complicated logic within Simulate. You just fill in your tables and your pro formas in Microsoft Excel. Press a button, the Simulate model opens, reads the data and configures itself accordingly with the correct number of custody suites. Those custody suites have got the correct number of booking in, booking out desks and cells. They've got the right number of resources to service them, or the resources you've specified in Excel. And the model will then just run and emulate what's happening in real life for 1, 2, 3 weeks or a year or what have you, at which point it will then end and write the data back to Excel, where you can then view some of the performance statistics within Excel. In terms of inputs, we're looking at how long does it take for booking someone in. And again, we often use a statistical distribution based on your historical data. How long does it take for prisoner processing? So taking them through DNA, fingerprint testing. What proportion of detainees require special needs, and how long do those special needs take to service? Things like a nurse or medical or what have you. How often are meals given, and exercise, showers and those sorts of activities provided to detainees. And all of that sort of time-based data can be given to the model within statistical distributions to make things a little bit more realistic. In terms of resources, we need to know the number of resources you've got of the different skills. So lots of forces are traditionally have used custody detention officers as well as sergeants. I know a lot of forces are moving away from outsourcing the custody detention officer, and they're bringing those people back into force now. So again, it's important to reevaluate where you're at with your custody model to make sure you get your number of custody detention officers right in custody. And obviously the shift patterns that they currently run is important, so we put that into the model. The demand, summary of the data demand stream. So very often we split the demand into compliant arrestees and non-compliant arrestees, and maybe drunk arrestees, so they can all have their different profiles for how long they're in custody for, or how long they take to book in. And this is provided to the model in an hourly and a weekly profile, along with some experimental targets that we're seeking to hit. In terms of facility configuration, we can put in the geographical sections, or the beats, the BCUs where people are arrested, the custody suite opening hours, the travel time data, and preferences such as which custody suite they should go to. Should they normally you're sending the person to the nearest available custody suite, and that's what you're setting there. That's just a screenshot of the Simulate model to show you it's a fairly uninteresting picture, but it's a model nevertheless that uses all of the formulas, and all of the algorithms within this model are pretty complicated, but it seeks to emulate what's happening in real life, is the main thing. And then the model outputs give you resource utilization by skill type and by hour of the week, the travel time and distance incurred during the year. So if you run one model with 5 custody suites and another model with 4 custody suites, you can look at the difference and start to quantify how much additional time is required traveling as a result of closing a custody suite. All the stuff around booking in, so how long people have had to wait in the queue before they've been booked in by the custody sergeant. We've got stuff about placement. So if I get arrested in BCUA, how often do I get placed in my preference 1 or preference 2 custody suite? Or how often is my preference 1 full and I have to go to preference 2? What does the cell utilization look like by hour of the week? And even just doing a static analysis of cell utilization around the country, normally we see anything between 15 and 25% utilization. It's a bit like the sort of beds in the Holiday Inn Express. Your main utilization comes on different days of the week, but in policing world, the custody suite, the cells may be utilized 80% on a Friday night and a Saturday night, but actually they're only utilised 5% during the week. So the average is often quite low, and it probably needs to be because you've got such a wide variation in your demand from a quiet period to a busy period. As I know a lot of you are going to be looking at custody suite location optimization and closing custody suites, I thought I'd pull up a case study from the archives, which looks at, I think it's Wiltshire Police. They had 3 custody suites, one up in Swindon, I think, one down in Salisbury, and one over to the west. This particular custody suite in the north was a PFI funded building, and we said, well, if you didn't have the PFI funded building, where would you put the custody suites? And interestingly enough, the one on the west was in about the same place, but the PFI one really should have been the other side of Swindon because of the demand is majoring round here. If we wanted to look at minimising travel time to custody, which is obviously the expense of police officers travelling to custody, the custody suite itself shouldn't have been to the east of Swindon. It should have been to the west. And actually, you look at the location here. This custody suite is of more benefit to the neighbouring police force, to sort of Thames Valley Police over the border, and by forcing the custody suite here, it means that the optimum location for the Salisbury one was Salisbury, but sorry, the one there was Salisbury, would have moved to the north of Salisbury. So these 3 are the optimum position. They're much more inbound of the force boundaries than the ones that were actually enforced upon them. So it is worthwhile bearing in mind when you're looking at the optimization to look at what a blank sheet of paper would look like. If I could build 3 custody suites anywhere, where would they be? Where would they then be if I was forced to use one in a certain location? So that gives you an idea. But nevertheless, this particular force were going for the 3 locations. They were closing one of their locations, the one in the south, which had very little use, and very simple calculation to see what that would mean in terms of hours travel. So if you look at a single vehicle travel time with 3 old suites moving to 2 of the current, closing 1 suite and remaining with 2 suites, you increase your travel by 912 hours per year. Now that's obviously 1 vehicle travelling one way from arrest to custody, but really you want to double all of that because you're going to have 2 police officers in the vehicle with the arrestee. So that works out at 1,800 hours increase per year. And then actually, if you think about it again, the police car's got to go from arrest to custody, and then it's got to go back out on duty to where it came from, either to continue its patrol and response or to recover witness statements and CCTV evidence from where they made the arrest. So actually we take the travel distance, multiply it by 2 for 2 officers, and then multiply by 2 again for 2 journeys. And that gave us a figure of 3,649 additional hours, or an increase of 51%. And that equated to 2.7 full-time equivalents. So by closing that 1 custody suite, yes, you save a lot of custody staff, but you do have, it does come at a cost of 2.7 FTE in response, and you've got to make sure you give those response hours back to response. Otherwise, you're going to fail. So the saving isn't 12 people at custody, it's 12 minus 2.7 full-time equivalents. And as I say, the optimum there was restricted due to the PFI site, and often PFI sites were not in the best place but had to be used. This forces a suboptimum solution, but now PFI is coming to an end in many places. There's an opportunity to review and optimize your locations. I mentioned the sort of estimating the process involved in custody, and this is something all worthwhile you're doing if you're reviewing your custody suite, and probably worth getting a few people together in the Wednesday webinars to discuss what pro forma you want to look like. But as I say, it's similar to Workload Profiler, elemental process analysis of each step of the process, backed up with some historical data where we can. So in our work, we've split the detainee process into 4 main areas. There's booking in, processing, detention in cell, or the supervision of the detainees in cell, and booking out. And then each area is subdivided by task, as you'll see in the following slides. And again, the thing here is to estimate and use historical data as best you can to work out the overall time. So from when you arrive in custody, you've got your booking in, your forensic sampling, catering for your detainee, and booking the detainee out. And that's the boundary of the model of what we're looking at. And once you've broken down these stages, we found back in sort of 2012, 2013 from memory, we've split the detainee booking in process into about 19 subtasks, forensic sampling into 17 subtasks, catering for your detainee in cell to 18 tasks, and booking out to 17 tasks. Here's an example. So we've got booking in activities. Authorising the detention is the sergeant, who does that 100% of the time. So we've got the who does it, the percent likelihood, how often it's done. Well, you authorise detention only once, and what's the duration? 2.7 minutes. And what we did, we sent these out as, or we've got these set up as a survey. So you might send this out to 10 custody sergeants to fill in their personal estimation of how long these individual tasks take. And then we've got a range of the min, the mean, the quartile 3 maximum, and quartile 1, and so on and so forth. So you can do some analysis to just see how things vary. So where we've looked at booking in, the sergeant time median is about 35 minutes. So the 19 booking in tasks break down to about a 35-minute median. There's not a lot of variance here in estimation. The CDO tasks is about 34 minutes. So again, if 2 or 3 of you were to do the same project, it would be very interesting to see how your similar tasks vary in time between the sergeants and the CDOs. We've then got forensic processing. So the sergeant's not involved much in forensic processing. That's mainly the CDO taking 45 minutes. And then in terms of detainee supervision, well, it's all down to the CDO here, making meals, giving them drinks, water, checking on them. They're spending about 70 minutes compared to the sergeant's 3 minutes on average. And likewise for booking out, we've got a 34-21 minute split. So that's all very interesting stuff. And again, if you were to start doing some benchmarking and comparison between yourselves, if Thames Valley, Hampshire, and Cleveland, and Hertfordshire as well, if you're doing a project, can sort of get a list of tasks together that you want to share between you, then it would be very interesting to see why one force maybe takes longer than another to do the particular work. Okay. The final element of this Wednesday webinar, well, has anyone got any questions on that so far? I shall take silence as a no, or you've all been cut off, or I've been cut off and lost internet connection.
Rob, I've got a quick question, if that's all right. So in terms of kind of accounting for that variation, so something that I'm kind of struggling with at the moment. So yeah, so that slide, I know it's slightly different, but I'm looking at case files and the processing of case files, and obviously that's very depending on what the case is. So it can take anywhere between sort of 30 minutes up to like 3 days sometimes. So yeah. Would you still take a similar approach to what you've done here, and take that median? But then I was just worried that taking the median could sort of almost skew the results sometimes because of those sort of anomalies that take so long to process, if that makes sense.
So I'd look at these bars, and if I had a massive outlier like this one here, I'd probably go back to that respondent number 4 and identify which of their particular steps they were a long way out on, or were they just over egging everything. And I might have a discussion to say, look, do you really think it takes that long? For your case file work as well, it'd be interesting to break this down into actually say really complicated case file development, middle level case file development, and easy case file development, and get them to not only estimate the time, but estimate the split. So that also can help you identify where people are over-egging the pudding. If they say that our complex case building files are 50% and medium is 5% and the easy is 45%, then again, you need to get a bit of an angle on that, so that helps you break down where they might be over-egging the pudding. Okay,
great, thank you.
Okay, so moving on to bespoke modelling, we had a recent project looking at arrests of protesters and taking them to custody and booking them in. And it was a very interesting project, but it wasn't really custody profiler and it wasn't response profiler. It was a bit of a mix. And we actually took the learnings from our response and custody models into a new model where we had the sort of model parameters again entered in Excel, fed into Simulate, where Simulate model self-builds and runs the model, emulating what we've told it to do, and producing the results back into Excel for review. Now, I thought this sounded a bit dull and boring initially, but actually I turned into quite an arrest process and process nerd, because it started to throw up some quite interesting issues for the police force that needed to book the number of vans they require for arresting and transporting prisoners, and also what would happen under COVID restrictions if they could only carry one person in a van and two people in a minibus. So we sat down and we did a process analysis to understand the flows. We got hold of some data sources. We got historic arrest data because we want to make sure we're not going to upset the business as usual work. So we've got to fit all these protesters in around the business as usual. And we got some example arrest data from protests that have happened at other forces. We built the simulation model and started to understand what's really going on. So in terms of the model boundary and the process map, we've got the process occurring. An arrest is going to be made. You're going to have to queue somewhere in a line for a vehicle on site where the arrest has been made. Then you're going to be put into the vehicle. The vehicle's then going to wait potentially for more people who are arrested, but there's only going to be a finite time before it has to go anyway. The vehicle's then going to have to travel to custody, and then it's going to be waiting at custody whilst it gets offloaded. Now, if the custody suite's got a holding area, you can offload the vehicle quickly and get that vehicle back round to pick up more customers. But if there's no holding area, or if the holding area is full, the detainees are going to have to wait in the van until there's space for them in custody, in which case they're going to queue in the holding area, they're going to get booked in at the booking in area, detained in the cell, and at some point they've got to be booked out, and then I've got a very sorry looking detainee being released there in my icons. I quite like these icons. So in terms of sort of a Gantt chart of what's going on, well, the arresting officer is engaged from the point of arrest until somewhere after the booking in has occurred. The vehicle itself is going to be engaged from when the arrestee is picked up to when they're dropped off in custody. And the offender is going to be engaged all the way through the process. So obviously we need to wait for the vehicle to arrive at the arrest location. In reality, we might call some vehicles forwards, or we might wait until we've got vehicles until we make arrests. I've got some sample screens. So all of these Excel screens were built for this particular bespoke model, and they're all in very similar fashion to workload profiler or response profiler or what have you, whereby you can only put in the data required, or you only need to put in the data required into these tables, and the model reads this data and builds accordingly. So that's a snapshot of the model. Doesn't look anything particularly exciting. It's just lots of lines and icons. Behind that model, there's a whole load of logic, though. There's a sort of what happens when the arrest is made. If you remember from sort of process diagram world, diamond-shaped boxes are questions where you can go either way. So is there a vehicle ready for me? No, there's not. So I find a suitable vehicle. Is there a custody suite available? Yes, I then allocate the vehicle to custody and all sorts of things. So there's a load of logic going on there around the arrest to make sure I get a van, I find an appropriate custody suite, and that the van's the appropriate for the type of arrestee. And built behind this, there's all sorts of questions about the type of arrestee. If they're non-compliant, they have to go in a cell van. Are they been doing a dirty protest? Do they have to go in special vehicles? Are they disabled? What have you? They might go in a taxi. So there's all sorts of questions within that get asked. And then when you arrive at custody, there's a whole load of other questions about what you do before you can release the van. So that logic was all discussed and programmed into the model. And when the model finishes, it produces some summary results, just showing you the number of people placed, process time summary. So how long were they waiting in the waiting for a vehicle? How long waiting in transport? The travel time, the waiting for offload, the waiting for booking in once they've been offloaded in the holding area, the booking in duration, detention duration, booking out duration, and so on and so forth. So we can build that up, and we can also see how many vehicles were used at most at different hours of the week. So this is just a summary. We then ran a range of scenarios looking at what the baseline would look like if it was unconstrained. Then if we constrained it with reducing the number of vehicles by a certain amount, if we could only have vans and no minibuses, what it would look like. And we started to find some improvements were happening. Things like if there was a COVID constraint, and what we found was there was more vehicles were spending, when you're trying to fill a minibus, the vehicle spends a long time waiting to be full before it goes off to custody, and when it arrives at custody it takes a long time to empty. So actually having lots of small vehicles means you're much more agile, and you don't need so many vehicles. You can get people processed through quicker. And actually, if you put too many people in a vehicle, you're shooting yourself in the foot in a protest situation, because you spend ages loading the vehicle, and that vehicle won't come back for another 3 hours because it takes a couple of hours to unload at custody. And also, if you've got people in the vehicle, if you've got 15 people in the vehicle, there's more chance that one of them will have a medical issue that requires the whole van to be diverted to the hospital. So there's a whole load of things there, which got me on to thinking how the queue moves. So if we start with the starting point of protest, arrest, queue, travel, queue, charge bar, detention, in a balanced system, the queues should be fairly manageable. But we can ask the question was, how will the queue move as the vehicles change? So what do you think would happen if we decrease the number of vehicles, for example? And because we're pushed for time, I won't wait for too long for an answer. But if we decrease the number of vehicles, we're going to get a shorter queue at the booking in point, but a longer queue of people waiting for vehicles, which doesn't sound too much of a difficult question. How about if we increase the number of vehicles? So here we go, we increase the number of vehicles. All we've done is we've shortened the queue here, but we've made a longer queue here. So great, we've thrown vehicles at the problem, but all we've done is we've moved the queue from the ground waiting to a vehicle to a queue of people waiting in the vehicles, which isn't what we want either. So let's look at what happens if we increase the vehicle capacity. Well, again, we get a shorter queue here because the vehicles can carry more people. But again, there's a longer queue of people waiting for the charge bar. So immediately, it's not just about vehicles. If we decrease the number of charge bars, sounds like a stupid thing to do. We get a long queue waiting for the charge bar and a long queue waiting for a vehicle. If we increase the number of charge bars, well, now we're starting to find out what's going on. We get a shorter queue here. Because there's a shorter queue here waiting for the charge bar, the vehicle gets released sooner to go and pick up people. So we get a shorter queue at the arrest point. So actually, although the initial problem was about how many vehicles do I need, we've got to take into consideration the number of charge bars. And actually having more charge bars is vitally important to getting vehicles back out to service. Likewise, having more holding area space. So clearly, it's all about the balance and having the correct number of vehicles and charge bars and the capacity of those vehicles. Increasing the number of vehicles moves the queuing from the open air to inside a vehicle, which probably isn't what you want. Smaller vehicles can offer a benefit because you have less time waiting to load at the protester site and less chance of having to divert to hospital or a delay for a medical, less time waiting to unload at custody. lower chance of requiring a clean after each trip, because if you've got a minibus of 10 people and one of them's ill in the van, you might need to clean the whole van. But if it's a small vehicle, there's only one person likely to be ill in the van. So there's a break-even point. Once you start traveling a long distance, that's when larger vehicles come into their own. But actually, if you're ferrying people over a short distance from city centre protest to city centre custody suite, you don't want to be putting too many people in your vehicles. So if any force has a need for modelling their protest in their area, then give us a shout, because we've got a model all ready for modelling that. Any questions and any idea of what you'd like to see next time? Anybody? Because we're scheduled for the 7th of July.
We're struggling at the moment with its the average wait time and how it's calculating that. It's saying the average wait time should be around 7 to 8 minutes. It's more like 30 in reality.
Which average wait time? To book in?
To book in, yeah.
Okay, so according to PACE rules, you should have a time they enter the airlock.
Yeah.
So that should be a golden rule. And then when the custody record is generated on the machine, the first thing the custody sergeant should do when they book someone in is create a record. So you should have the record creation date time. So I suppose the distance between the queue time is from coming through the airlock to opening the record. You're saying that's 30 minutes, but your model's only saying 7 minutes.
Yeah.
Okay, I suspect some of that will be that in reality, the custody sergeant will be doing other things whilst an officer brings someone in, or may not be as focused on turning the machine on and booking someone in as perhaps they should. You often find that sort of behaviour. They might twiddle their thumbs for a few minutes before opening that record, but generally we do find when we build the models they get closer than that. So there may be something you're missing with what the custody sergeant's doing as other activities. They may need to be higher priority activities. If they're booking someone else out, should be a higher priority than booking someone in. Maybe making meals will distract the custody sergeant more than it is at the moment.
Okay.
So you might need to play around with some of your prioritisation of other tasks.
Okay, I'll have a word with our custody inspectors. Thank you.
Yeah. Okay. Any ideas for next session? I was just wondering, would there be any mileage in trying to build up a list of what you think would be a sensible elemental list of things that custody should do looking in? Or any other processes you're looking at with Workload Profiler? If any, we did some work with vetting last year where we built a standardized list of what you do when you vet someone for recruitment vetting and management vetting, and we shared that with the countrywide.
It would be quite interesting, I think, Rob, because its pace is the same in every force, and I think it'll eventually would spin over into case file preparation, isn't it, really? Because it should be universally the same with because the file standard is national. We are aware of local nuances, but they all should be the same, shouldn't they, really?
Yeah. Okay, so if I put together the template of what we've got for those steps of the process and send them out to everybody in the group, you could then look at that list and just tick yes or no, we do that, or yes, we do it, but we call it something different, and then list out the things you do in addition. We could then have a bit of a couple of slides just going through those to see if there's things that just sort of colour them in by different colours by different force. If it's the same everywhere, it'll be black, and then if it's a different force, we'll just put in new colours so we can compare and contrast the activities, and then that gives us a template you could take away and populate with some values for the following month, do a bit of benchmarking perhaps.
Sounds good.
I shall put that down as an action. Okay.
Rob, would you send the slides out from today's session?
I will indeed, and I think Ali was going to make the video available on the website as well.
Great. Okay. Thanks.
Gives me the opportunity to look back at my performance for a change.